Volcanoes. What would it be like to watch a huge volcano erupt? The photos on page 326 and 327 give you some idea, but you have to imagine the terrific heat, the choking ash, and the streams of molten lava that threaten to overtake you. A volcano is an opening in the Earth's crust that releases lava, smoke, and ash when it erupts, becoming active. The openings are called vents. When volcanoes are not active, they are described as dormant. Scientists try to predict when volcanoes will erupt so that the people living near them can avoid injury or death. I climbed up a volcano, part of the way, Mount Etna, in 1985, early 1985, and it was very dramatic. It was during a blizzard, not a recommended time to climb up any volcano. It was very cold. Types of volcanoes. Imagine watching a volcano form right before your eyes. A farmer in Mexico had this experience when a hole in the ground in one of his fields suddenly sent clouds of ash, smoke, and glowing cinders into the air. The activity continued for several days. The ash and cinders cooled, fell to the ground, and eventually formed a volcano called an ash and cylinder cone. The ash and cylinder cone is the smallest type of the three main types of volcanoes. It has gently sloping sides, a large bowl-shaped crater. Paricutin, the volcano that formed in the Mexican farmer's field, is now several hundred meters high. Figure 11.14a. Mount Pinatubo erupted in the Philippines in 1991. The huge amount of ash blown out of the volcano formed an ash layer within the atmosphere that circled the globe and cooled temperatures around the world. And figure 11.14b, ash and cylinder cones are built from layers of ash and rock and are usually less than 300 meters high. And 11.15, this is the volcano Paricutin in Mexico, erupting in 1943. The Hawaiian Islands are examples of the second type of volcano, the shield volcano, figure 11.16a. The shield volcano is the largest of the three main types of volcanoes. The most well-known example of this type of volcano is Mauna Loa in Hawaii. It is so huge that it is an island growing up from the bottom of the Pacific Ocean. It is so large, it is the largest of all the Hawaiian islands. It is shaped, and it's the island that Mauna Loa is on is called Hawaii. I'll put a picture there. This type of volcano is constantly active, sending out lava most of the time. If you travel to Hawaii, you can visit the area where the volcano is active and see the lava flowing. The shield volcano does not erupt violently as the ash and cylinder cone does. Scientists have collected information indicating that a hotspot under Hawaii is responsible for the volcano activity there. See figure 11.17. A hotspot is a location where the temperature under the crust is much higher than elsewhere. As a result, lava is forced upward through cracks in Earth's crust. The people who live in Hawaii see lava flowing almost continuously from Mauna Loa. See figure 11.18. Did you know one of the worst eruptions in history occurred on August 27th, 1883, when the volcanic island of Krakatoa in Indonesia literally blew up. The blast was heard 4,800 kilometers away. At least 32,000 people died when tsunamis reaching 30 meters in height were triggered by the eruption. Did you know a new volcano is forming under the ocean right beside the main island of Hawaii? It has already been named Loei. It will continue to grow until it is another island in the middle of the Pacific Ocean. Perhaps your descendants will visit Loei in the future. Did you know tourists can visit the Hawaii Volcano National Park to see the top of the volcano, Kilauea? Clouds of steam fill the air, and the odor of rotten eggs is noticeable. What do you think causes the odor? Hint, some of the ground is a yellow color. It's called hydrogen sulfide. Did you know Mount Pinatubo in the Philippines is another example of a composite volcano? It was the largest volcanic eruption of the 20th century. It has been dormant for about 600 years before it erupted in 1991. Figure 11.17. This illustration shows the Hawaiian island chain stretching north in the Pacific Ocean and the hotspot that has created it. The northern islands in the chain no longer have any volcanic activity. They are also much older than the southern islands. What clue might this give you as to what is happening in the Earth's crust? Figure 11.18. Tourists in Hawaii can watch the lava flow into the ocean and listen to it sizzle. Like earthquakes, volcanoes can be formed when rock surfaces beneath Earth's crust push against one another. The part of the crust that is pushed downward reaches very hot areas that it melts and becomes magma. Eventually, there is so much magma, it is forced up through openings and erupts. The third type of volcano is called a composite volcano. The eruption may be violent, as in an ash and cylinder cone, or quiet, causing lava to ooze over the cylinder layers, as in a shield volcano. Mount St. Helens in Washington is an example of a composite volcano. The rock on one side of the mountain began to bulge out in the days before the eruption that occurred in 1980. Scientists knew that an eruption would happen soon, so they had time to warn people to stay away from the area. The eruption literally blew away the side of the mountain. Figure 11.19 below shows how magma built up inside the volcano to cause the eruption. You can see a cross-section of a composite volcano in figure 11.20 on page 332. So here is Mount St. Helens in the process of eruption. Figure 11.19, volcanoes erupt in stages over a period of several weeks, months, or even years. So A is March 20th, 1980. B is April 23rd to May 18th, 1980 at 8:27 a.m. And then May 18th, 1980 at 8:32.41 a.m. And then D, May 18th, 1980, 8:32 and 52 seconds a.m. So it starts off on March 20th, and then by May 18th at 8:27 in the morning, and what is that? 5 minutes later, 5 minutes and 41 seconds later, 5 minutes and 51 seconds later, it erupts, and it is very, very, very violent. Famous volcanoes. Probably the most famous composite volcano on Earth is Mount Vesuvius in southern Italy. Many scientists believe that Vesuvius, dormant since 1944, is due for a large eruption. A huge area beneath the peak is filling with magma. The situation is even more dangerous because the opening at the peak is sealed by a rock plug. Scientists have produced computer simulations to show that when the pressure forces the rock plug out, a cloud of molten rock, ash, and gas will blast about 1.5 kilometers upward. It will probably stay in the air, held up by heat from the volcano. Then, after several hours, it will drop to the ground and flow at about 160 kilometers per hour. This terrifying cloud is expecting to reach Naples, a city of 3 million, 5 minutes after the volcano erupts. Currently, there is a great deal of discussion over the appropriate measures that must be taken in case such an event occurs. Look again at the volcano map you made. Run your fingers around the edge of the Pacific Ocean from New Zealand north to Asia and down the west coast of North America and South America. Can you see all the volcanoes in the circle? These volcanoes around the Pacific Ocean make up the Ring of Fire. The name comes from the circle of volcanoes that pour out red-hot lava, fire, and smoke. Mount St. Helens, Mount Pinatubo are part of the Ring of Fire. Most volcanoes in the Ring of Fire occur at subduction zones. Figure 11.20. In a subduction zone, the descending rock moves deeper and deeper until it melts into magma. This magma rises up through cracks in the rock until it exerts enough pressure to cause the volcano above to erupt. A blast from the past. Mount Vesuvius is a volcano with a colorful past. What to do? With a partner, choose one of the major eruptions and find out what you can from books and from the internet. See what you can learn about something called pyroclastic flow. Why is it one of the most deadly parts of an eruption? Organize your findings in the form of an annotated poster, a storyboard, a booklet, or a demonstration live or on video that you can present to your class. Key dates in the history of Vesuvius. 300,000 BCE, molten rock is forced up between two major rock surfaces to form Mount Vesuvius. 25,000 BCE, oldest dated explosive eruption occurs. AD 79, first historically recorded explosion occurs. At least 3,000 people are killed in Herculaneum and Pompeii. 472, eruption causes destruction in northeastern region around Mount Vesuvius. 1631, coastal regions around Mount Vesuvius are destroyed. Eruption kills more than 4,000 people. 1794, lava destroys town near Vesuvius for a third time in 170 years. About 400 people are killed. 1906, lava and explosions cause destruction of nearby towns. More than 500 people are killed. 1944, mild eruption causes 26 deaths, due mainly to the collapse of a building. Extend your skills. Design your own with your team. Plan the materials you would need and the steps you would take to build a working volcano. Harnessing Earth's energy. You have seen the Earth's interior contains a tremendous amount of heat. Scientists have begun to harness the energy that exerts such incredible force many kilometers under the Earth's surface. The intense heat deep inside Earth has been harnessed at hotspots in more than 20 countries around the world. At such hotspots, Boiling water or steam occurs naturally throughout the rock in areas where magma is close to Earth's surface. This water or steam is piped to a power plant at the surface. There it is channeled through a control system to turbines and is transformed into electricity. The energy that we harness from Earth's interior is called geothermal energy. Unfortunately, geothermal energy exists only where magma is close to Earth's surface or where geysers are located. Geysers are caused by Earth under the ground being heated by magma, figure 11.21. Geysers are found at various places on Earth's surface, as well as being an alternative to our dwindling supply of fossil fuel. Geothermal energy is clean, and the power plants that convert it to electrical energy are reliable. Such energy would help to reduce the threat of oil spills, wastes from the mining of fossil fuel, and pollutants from their use. Where magma is too far beneath the surface, scientists are finding ways to use geothermal energy. A technique called HDR, hot, dry rock, is used to pump water into rock that has been cracked, figure 11.22. The heated water returns to Earth's surface as steam, where it helps to generate electricity. At present, this process is expensive, but it could be an alternative to fossil fuels in the future. Figure 11.21. Examine the cross-section of a hot spring and a geyser. Both could be harnessed for geothermal power. British Columbia has more geothermal energy than other parts of Canada, but for a number of reasons, hydroelectric energy remains the main focus of development at this time. And then you have the diagram, which is fascinating to look at. And then you have a geothermal power plant and how that works. And that says, figure 11.22, a geothermal power plant.